So Unit 2, we're going to look at geometry. In the first section, we're going to look at area applications. And we're going to start off with an example. So Jennifer has a summer job working at a golf course. Before the course can open in the spring, the old carpeting needs to be inspected. If it's too worn, Jennifer needs to calculate how much carpeting is needed and replace it. The design for one hole of a miniature golf course is shown below. And note the curve at the end is a semicircle. So we want to determine the area. We want to determine area of this region. And the best way to do so is to split this up into the 4 geometric shapes that you might see here. So our first shape here we have is a trapezoid. Our second shape here is another trapezoid. Our third shape we have is a rectangle, and our fourth shape is a semicircle. So let's go through each of these shapes one at a time. So let's start with shape 1, the trapezoid. So first thing is to find the formula for the area of a trapezoid. Going to our formula sheet, we can find our trapezoid, and we can see that the area is given by a plus b in brackets times h divided by 2, where a is the length of the top part, b is the length of the base, and h is the height of your trapezoid. So again, let's write our formula. So we have that the area of a trapezoid is equal to a plus b times the height of the trapezoid all over 2. So let's redraw our trapezoid here. So if I rotate it, there's the 2 parallel sides. We have 1.2 meters at the top, so that'll be our A value. We have 2.1 meters for the bottom, that'll be our B value. And where the 90-degree angle is going upwards, that is our height of our trapezoid, which is 2.3. So let's sub in our numbers. We have 1.2 plus 2.1 times 2.3 all over 2. So let's type this into our calculator. And if we type this in, we get that the area of 1, I'll put a little subscript here, is equal to 3.795 meters squared. Since we're dealing with 2 dimensions, we have to have square units. Alright, so there's trapezoid 1. Let's now find the area of trapezoid 2. So using the same area formula, area equals a plus b times h divided by 2. And this time our trapezoid looks more like this. Let's go back to the top. The top part is 1.8, the bottom is 4.6. So this time 1.8 equals our a value, 4.6 equals our b value, and in the diagram above, that the height is 2.07. So let's sub in our values. We have 1.8 plus 4.6 times 2.07 all over 2, which tells us the area of region 2 is 6.624 meters squared. So that's our second area. Going back to the diagram, our third area is a rectangle, which is 2.5 by 4.6. So let's add that one in. So our third area is our rectangle. And recall that the area of a rectangle is length. The area of a rectangle is length times width, which equals 2.5 by 4.6. So 2.5 times 4.6, which gives us that the area of section 3 is 11.5 meters squared. And finally, we have part 4, which is our semicircle. So for semicircle, region 4 here, we have the diameter is 2.5, shown over here. So the radius is half of 2.5. So we have a radius of 1.25 meters. And if we look at our formula sheet, we'd see that the area of a circle is pi r squared. So the area of a semicircle is going to be pi r squared divided by 2. Half of a circle. So we get pi times 1.25 squared divided by 2. And our final section has an area of 2.45 meters squared. So this one's the approximate answer. So if we want the total area, we need to take the area of 1 plus the area of 2 plus the area of region 3 plus the area of section 4. And we need to add these all up. So we need to go back up to the top here. We have 1, 2, 3, and 4. And what I get is an approximate area, and the total I get is approximately 24.4 meters squared. So this is the area of the grounds she needs to cover. All this here. So part B. If carpeting costs $2 per meter and it only comes in rectangular sheets that are 2.5 meters wide, so notice the widest this course is 2.5 here, so we're going to have some waste here when we put the sheet down. What is the cost to replace the carpeting? It only comes in rectangular sheets, so let's start again with the 4 different areas and how much material do you need. So let's start with 1. If I have a rectangular sheet, I gotta buy it as a rectangular portion. So there is what I'm looking for. So the amount I need, since it's already 2.5 meters wide, I just need to buy a length that's 2.1 meters long. So for region 1, I need 2.1 meters of carpet. Alright, let's go to section 2. Section 2, I need enough to cover this, but remember you can only buy it in rectangular sheets. There's going to be some waste. So there's the next piece I need, right? So this is going to be like the waste when you cut it away. But I need a sheet now that's 4.6 meters in length. So 4.6 meters of carpet. Okay, now we go to section 3. Section 3, hopefully you can see, we're not going to have any waste. It's 2.5 by 4.6. So we need 4.6 meters again to cover up the third section. And now we have the fourth section here. And this length here that we're looking for, the amount of carpet we need to buy, remember is the radius of the semicircle, which we figured out in the first part is 1.25 meters. So for section 4, I need 1.25 meters from that roll. So in total, if we add these all up, we get 5, 12, plus 3, that's 15, carry the 1, so 7 and 5. I need 12.55 meters of carpet in total. So you'd call the company and say, I need this much, probably a bit extra just in case you make a mistake. So what is the cost? Well, we need 12.55 meters, and it's $2 per meter. So let's figure out the total cost. So the cost is We know we have 12.55 meters times $2 per meter equals approximately $25.10. So therefore, the total cost is $25.10. Last part, how much extra carpet do you have? Because remember, we bought these in rectangular sheets. So let's go through this really quick to explain again. When I cut it out, I'm going to waste all this area here. This rectangle's pretty good. It's done. This one's 2.07 meters wide, so when you buy the rectangle, it's going to be a bit wider than the area, so you're going to waste all this space here, and since again it's a rectangle, we're going to waste some space here. And then the bottom one, same idea. I'm going to buy a rectangular sheet of it, and then I'm going to waste a bunch of, when I cut it, waste all this space here. So we're trying to figure out how much waste do we have at the end of this. So we know from part A that the total area was 24.4. So we're going to take that. So let's add that here. So we had the total area as 24.4 meters squared. That was the total area. That's from part A. And then from part B, we needed 12.55 meters of carpet. But remember, we have 12.55 meters of carpet, but we also have it that it's 2.5 meters wide. So we need the area. So this is all from part B. So remember, area equals length times width. We bought 12.55 meters of length, but it had a width of 2.5 meters. And all you're going to do is subtract these numbers to see how much extra or how much waste you have. So 12.55 times 2.5 minus 24.4. So I ended up with 6.975 meters squared that is wasted, or approximately 7. Therefore, you will have approximately 7 meters squared of extra carpet. Remember, there'll be offcuts, angled cuts. They might not even be useful. Let's do one more area application. This one is going to involve a mix of trigonometry as well. So I want to know how much siding is needed for the face of this home. Remember, the siding is just going to cover the face. So I'm going to cover this triangle up top, this rectangle here, and I'm going to leave the door open. I'm not going to put any siding on the door. So we need to find out the area, because we're looking for how much siding, how much area it's going to take. In this one, we actually have 3 different shapes. We have the triangle up top. We'll call that shape 1. We have the rectangle here. And then we have a third rectangle that we don't want to use. So we're going to take the area of region 1, add it to the area of region 2, and then minus the door, because we don't need to side the door for this house. But we have to look for all these different areas. So first of all, let's start with the triangle. Remember, the area of a triangle is base times height divided by 2. So we already have the base of this triangle. It's right here. The base of this triangle is 8.53. So let's just redraw it. It is 8.53 units. All we need now is the height of this triangle, which we do not know. However, we do know that there's a 22-degree angle in the corner of this triangle, right here. I'm going to redraw half of that triangle. Here's 22 degrees. I know that this is 8.53 divided by 2, which equals 4.265, and I want to know the height of this triangle. If I look at this triangle, my angle of focus is 22, and this would be the opposite side, this would be the adjacent side. So I'm going to use my tan ratio. So the tan of 22 which I know is equal to the opposite over the adjacent. And I'm going to solve for the height of this triangle. So remember, our next step is to isolate for h. So I'm going to multiply both sides by 4.265. And I get that h is equal to 4.265 tan of 22, because these cancel out. So using my calculator, I get that the height of that triangle is approximately 1.72 meters. So let's just round to 2 decimal places. So now I have the height of the triangle. So we have the base is 8.53, and I have this height is 1.72 meters. So if I want the area, my area is going to be 8.53 times 1.72 over 2. And that gives me an approximate area of 7.34 meters squared. Remember, we're dealing with area, so it's 2 dimensions. All right, area 1 done. Let's go to 2, the rectangle. Remember that the area of a rectangle is length times width. So in our example here, we have the area is equal to 5.75 times 8.53. And we're done. So 5.75 times 8.53 gives me an area of 49.05 meters squared. So there's the area of the big rectangle. That's this one here. All right, we still need to figure out rectangle 3. That's this one here. So rectangle 3, so the area of rectangle 3. So the area of the rectangle. Again, area equals length times width. So I'm going to have A is equal to 2 times 0.75, 2 times 0.75, which gives me 1.5 meters squared. All right, so we have the area of 1, the area of 2, minus the area of 3 will give us the total area, or the total amount of siding that we will need. So let's do that calculation. So the area total is equal to 7.34 plus 49.05 minus 1.5, which gives me a grand total of 54.89 meters squared of siding needed. So again, we're dealing with area applications. So split up the areas into different geometric shapes. Use your formula sheet to help you calculate the areas, and then conclude. Here are some questions you can try, and good luck.